flexible DC converter valve. Distinguished Chairman Liu, experts, business leaders, good afternoon. Here, I want to thank the organization of GEI to provide XD an opportunity to brief to you what we have done on VXC HVDC. Mainly, I want to talk about the 800 kV VSC HVDC converter. My presentation is divided into 4 parts. You already know the basics about VSC, so I will give you a brief introduction of the subject. GEI is based on UHV power, mainly based on transporting renewable energy. It connects large-scale clean energy bases and various distributed power and delivers clean energy to users. GEI is a platform with wide range services, high transportation and distribution capability, highly reliable and low carbon. VSC UHVDC is the best way to build the mainstay of the global energy network. It's based on voltage source converter, PWM technology. It's more advantageous than LCC HVDC. There are a few features, and these features have supported us. First of all, it adopts fully controlled power electric devices. Secondly, it provides dynamic reactive power compensation with active power and reactive power. Thirdly, self-commutation without commutation failure. And fourthly, low harmonics, no need for AC filters. And technology-wise, this is leading the way. Application areas: renewable energy access, asynchronous interconnection of AC power grid, construction of DC power grids, and power supply to passive systems and weak AC systems. This is an evolution map, and started from 1990s in overseas till this moment. In China, it started from 2011. During the 12th or 13th five-year plan, VSC HVDC started to be applied. Now, for the 800 kV VSC HVDC converter, started from the 13th five-year plan, it's listed as a national key R&D plan. It's a key technology demonstration for high voltage and large capacity VSC HVDC. And it's a mixed multi-terminal line. What we did was the valve. Now, from systems perspective, first of all, the voltage is the highest in its category, and secondly, self-eliminating of DC faults. And the majority of the time, the lines are in the air, above the ground. So we have to solve the problem from topology perspective for eliminating DC faults. And secondly, it's a hybrid HVDC. The sending side is LCC. The receiving side is composed of 2 VSC, 3,000 megawatts. The other one is 5,000 megawatts.
So with regard to 800 kV 5,000 megawatt VSC UHVDC converter, we have used half-bridge and full-bridge hybrid power modules to satisfy the purposes of adopted this kind of half-bridge and full-bridge topology to make sure that the converter can respond, can perform some self-healing or self-fault removal. Let's take a look at rated power is 5,000 megawatts rated DC voltage, plus minus 800 kV and LIWL, 1950 kV SIWL, 1600 kV. Anti-seismic rate is equal to and greater than level 8. And the losses can be controlled at equal to 1.0%. The topology of the power module. The 800 kV VSC HVDC converter. We have the circuit, the power devices, the controller. And let's take a look at the power source. It's 400V DC. Now let's then take a look at the power module we have developed. This is the voltage stress of our power module. In developing the power module, we must address electrical design, losses calculation, explosion-proof design, water cooling design, EMC design, and control system design. For the high-end anti-interference EMC design, we've carried out an all-round research, having conducted a host of experiments. And then the valve section design, we need to make it a high load bearing and large span valve section insulation support, making it easy for the maintenance. That's a holistic approach in designing the valve section of tower. And we are raising the anti-seismic and the weight-bearing capabilities. Let's take a look at valve and CMP design. It features a higher grade at millisecond response. At VSC DC, it is a microsecond response. And in the internal control systems, we're making sure that our microsecond response is ensured from the perspective of valve CMP. And you can see the design of a high-speed backplane bus and intensive optical module, circulating current inhibition algorithm, voltage balancing strategy at low switching frequency, fast over current protection strategy, charging strategy for hybrid converter, maintenance mode, and modules comparison function. Previously, we've talked about the full bridge, half bridge configuration, and we can automatically tell or identify whether it's in the half bridge or the full bridge configuration. That's the valve section operation tests with the witness of the National High Voltage Apparatus Quality Supervision. The operation test of the valve section has been successfully completed. Test of the valve tower of the prototype. And then the valve CMP, the control system. In terms of the function test has been completed on RTDS and RTLAP at a microsecond control level. We are making sure that a valve control system is up to performance standards. In order to better test the capabilities of our components, we have put in place and plus minus 10 kV 600 megawatt back-to-back system, so that this system can be used to verify the performance of a hybrid valve and a valve control system, which consists of a half full bridge power modules. It can perform a lot of functionality tests. Well, then talking about this product technical identification, the developed plus minus 800 kV 5000 megawatt VSC HVDC converter adopted the logical achievement identification organized by the relevant industry body. And the technical performance of the product is the state of the art in the world. It can achieve control at the microsecond level while performing conventional controls. For the multi-terminal VSC HVDC converter, this product will go a long way in ensuring an effective and reliable ultra-long distance electric power transmission in our country. Well, then, a few words of summary. China XD possesses the innovation and industrialization ability of VSC converter and the valve CMP system development, test and manufacturing through the R&D of plus minus 800 kV 5,000 megawatt converter and valve control equipment. China XD is capable to provide key equipment and technical service with high reliability and quality for VSC UHV DC projects, which can go a long way in making sure contribution is made to the development of GEI. We've shared with you a lot of our methodologies and capabilities for our equipment testing, and well, there's of course a lot more that we should do. Thank you very much for your attention.